Alright, for number 1, we have to solve for x, and we have to round to the nearest tenth. If you look at our right triangle, we're given two sides. We're given one side length is 5, and the hypotenuse, because it's opposite the 90, is 17. So if we're given two sides of a right triangle and we need to find the third missing side, we could use Pythagorean theorem, which is a squared plus b squared is equal to c squared. If you remember, a and b are the legs of the right triangle and c is the hypotenuse. So in this case, c would be equal to 17, and it doesn't matter what you plug in for a and b, the legs, because you're just squaring those and adding those together. So I'm going to choose 5 as a, and I'll say my b is x. So plugging this into the Pythagorean theorem, we would have a squared, so 5 squared, plus b squared, which is x squared, is equal to c squared, the hypotenuse squared, so 17 squared. So solving for x, we need to square the 5 and the 17 first, so 5 squared is 25, plus x squared, and that's equal to 17 squared, which is 289. So our job here is to isolate the x. So in order to get the x alone, I need to move the 25 to the opposite side. So subtract 25 from both sides. So we get x squared, and that's equal to 264. So now that x is isolated, we still need to get rid of the power of 2 attached to the x here. So the opposite of squaring something is square rooting. So we square root both sides. So x is approximately, we'll type this into our calculator because 264 is not a perfect square. So if you type this in, we get 16.2 rounded to the nearest tenth. And that makes sense because if we look at the right triangle again, x is not the hypotenuse. The hypotenuse is 17, so x should be less than 17.